We're here at the Irrigation Resource Foundation in Yuma, Colorado with Stan Evans. And he's here to talk to us about APSA80 and the alleviation of compaction by using it.
Okay, thanks, Scott.
Thanks, Stan.
And I believe that APSA80 is going to be a real saving product for an awful lot of farmers, to be a difference between maybe breaking even and losing money or making money. I'm going to just draw you some pictures, and first of all, what I probably should do is make sure that you educate the farmer of what a surfactant is and how it breaks down the surface tension of water. And when you do that, what happens when an irrigated field or a dry land field. Well, it doesn't make any difference whether it's flood irrigated or sprinkler irrigated. And of course, need to educate that farmer, some good demonstrations to do that, maybe a evaporation chart to kind of inform him as to how much water evaporates in a 24-hour period of time. So I'll just go to the board here and draw you some pictures, and maybe it'll help everybody out a little bit to understand what happens with water. I'm going to just assume that maybe we're out here in a field and we've taken a trencher or something, and we've dug a hole, dug a trench, and we can get down in that trench and have a profile here as to taking a look at the dirt and the roots and everything, how it might look. Let's say here's your stock of whatever it might be. That can be corn, beans, alfalfa, any kind of plant that grows in soil and needs water. Then you got your root zone that comes out here. Okay, so now we're looking at this profile, and we're going to add water. Now, water is going to come in the form of irrigation, probably from sprinkler irrigation or flood. Can be natural rainfall. That'd be the same. Anyway, water comes. 4 things will be happening. What we'd like to, and out of the 4 things, only one is really beneficial. What we'd like to do is make that one more beneficial and the other 3 less prevalent. Now, here's what can happen. If water doesn't penetrate very well into the soil, then of course what it wants to do is run off. And it may not run out of the field. It may just run over a few feet, finds a spot, maybe a crack in the soil or something, and then it goes down there. Generally, you can notice that in the field by looking. If you get up and look across it, you'll see unevenness, and that's generally not a very good distribution of water. And that could be one of the causes for that uneven height. But anyway, you're losing water, and of course it can run clear out of the field. You see that happening a lot too. The other thing that happens if you got any compaction or water doesn't soak in very well, then the water wants to come back, stay on the surface, and of course then it evaporates. And of course our evaporations charts show us that you can lose 25 hundredths, 30 hundredths, up to 40 hundredths of an inch of water a day in a 24-hour period. So evaporation is one of our big enemies out here in this part of the country. So we want to alleviate that. The other thing is, if you have a kind of a sandy soil where the particles are kind of far apart, you can get leaching where it leaches clear out of the root zone. When it does that, of course, you lose your water, and it'll take some nitrogen with it too. So you don't want that to happen. If you've ever looked at a particle of soil under a microscope, and this is kind of important, if you get a chance to do that, or find a textbook or something where you can actually get a visual look. I ask a lot of farmers, have you ever looked at a particle of soil under a microscope? Hardly any of them ever have, so they don't really understand that part, so you need to kind of explain it. If you look at a particle of soil, I'm going to have to change my deal here. Supposed to suck on these, right? Anyway, if you look at a particle of soil under a microscope, they look like some people explain, or if they've seen them, say it looks like a jigsaw puzzle part. And this is how they're just jagged and got valleys and crevices, and this is just all kinds of shapes. If you have something like where they're stuck together like this, then you got compaction. Now compaction can be a layer of compaction, or it can be an area of compaction. Where some of these have stuck together, what happens, roots tend to come down and can't get through there, so they go along here and they try to find a spot. Maybe they can find a spot and sneak through, but that takes effort for that plant to do that, and it robs it of its yields. Maybe it gets down here, and then it gets to here, goes around this area. So what you want to happen when water comes to that surface, not to soak in rapidly, so that it's not setting on the surface and evaporating, because what you want it to do is, as it comes in here, penetrates each particle, right, because you broke down the surface tension with APSA80, and then it wants to surround this particle of soil. Know how it did with that piece of cardboard? How it beat it up and just would roll off. Now if you break that surface tension, how it wanted to soak in, that's what it's going to do actually to each particle of soil. So as more water comes, and it does it to this one, and begins to make this really mellow, you can get this root zone area to hold a lot more water. And when you hold a lot more water, if you have stress, then this plant needs that water. You got more of a reservoir to draw from. So naturally, if you can get in a foot of soil, maybe it's holding 2 inches of water. If you can get it to hold 2.5, 2 3/4 inch, 3 inches of water, you got a big reservoir to draw from that you wouldn't have had before. You'll see in a lot of cases, one field of corn that hasn't had APSA80, and a hot day it's rolling, the corn's rolling. Look at another field and it's not. How's it come? Because it's got this reservoir of water in here because you've used APSA80. And then if you got some compaction, it softens that up, allows the roots to penetrate through and loosen that up. So you just get more water in your root zone, allows the roots to spread out more and to go deeper. And of course we've got a lot of tests. Some of the results we've done out here at the research farm shows we got a lot more penetration. Roots go a lot deeper, and with using APSA80, and so we got numbers to back that up.
Are you Roundup Ready corn?
We generally use Roundup Ready. We make one pass through the field planting, one pass through the field to kill the weeds.
And when you use Roundup, do you use APSA80 with your Roundup?
Mm-hmm.
What does it do for you for Roundup use?
Well, and this is something I'd want to caution people on, Scott.
Okay.
Because we cut back on the amount of Roundup we use per acre because we know it enhances it. Because it does enhance it, we take that into consideration, so we're using less Roundup too. If you didn't do that, I'm always a little cautious about using it and maybe getting some crop damage. So it's just something to consider, and maybe, and so I don't know, you know, I just would want that to be a caution. The other thing that I'd like to mention though is APSA80, especially through a pivot sprinkler or ground rig spraying, is a great contact insecticide.
Really?
We haven't sprayed for insects, mites, corn borer, any of those things for years because we're injecting our APSA80 generally with our nitrogen, liquid nitrogen, through the system. Right. And so we're getting some APSA80 out there, and that controls the insects. Because if, just like you did on that piece of cardboard, if that insect has a waxy coating, correct, and water and APSA80 breaks down that coating, washes it off or washes enough off that they just die from natural causes from bacteria in the air. And it doesn't seem, ladybugs and those type, doesn't affect them because they have a shell instead of a waxy coating. Like a grasshopper, they don't have a shell or kind of a waxy coating. You wash that off, they'll die.
So basically it leaves your predatory bugs alone, your beneficials, and kills your harmful bugs.
Yes, it's kind of amazing. It's just like a miracle.
Yeah. That's impressive.
So by continuing year after year using APSA80, with this, especially with this practice of injecting it through the pivot sprinkler during the season, we control our insects. Now we have had times when we get a infiltration of grasshoppers. We just go in there and put about 10 ounces to the acre and run that sprinkler as fast around as we could, putting on like 1/4 of an inch.
Right.
And that would be, that 10 ounces cost a couple dollars, and we would control them well enough that we didn't have to hire a commercial sprayer.
That's impressive. What would you say an insecticide would cost per acre, just if you need to go and kill them, including application costs?
Normally it's somewhere between $6 and $10 an acre. Big thing is it kills everything. I mean, it kills your natural predators that gonna eat the. So then you end up with a field with no ladybugs or any of the others. So you kill everything. In fact, is generally when they do that, you can't even go in the field for 2 or 3 days. So using APSA80, it's natural, and besides that, it's not going to hurt the soil. You're going to get more benefit over here.
So you basically use a little APSA every so often when you're putting your fertilizer down on top of your initial, where you put it down after pre-plant or post-plant.
We make a plan that we're going to put on 15 to 20 ounces a year per acre. We may save back some, but every time we're putting on putting on some nitrogen or some fertilizer, injecting it through the pivot, we got some APSA80 in there. There's another benefit. Nitrogen, pumping it through a pivot sprinkler or any kind of machine is a corrosive.
Okay.
So you corrode up the nozzles, but when you add APSA80, it doesn't do that. So it's just kind of a natural lubricant that takes care of that problem at the same time. So anyway, it's pretty amazing. That's
amazing. It is a natural lubricant. Just try putting some APSA80 in a container that's not qualified to hold it, and it gets out. It really, we've learned the hard way. A water bottle doesn't hold APSA80.
Yeah.
But those are some of the things that we were looking at. Is as you look at this, you have savings in inputs. You also have savings in bug control. You also have savings in water and a yield increase.
Sure.
So basically, with proper management, you could see somewhere on a cornfield of savings in profit of almost $100 per acre.
Sure. It's an amazing product when you analyze all that it'll do. And of course, normally we thought of it in the beginning as some way to alleviate compaction, and it does that. I would like to say that it's an ongoing practice. It's just not a one-time deal. So anyway, if you can plan on, and that's the other thing to think about. It's not that expensive. It's cheap, and it does so many different things that if you're really aware, it's pretty phenomenal how $3 an acre, $6 an acre makes that much difference.
What I like to say is, Stan has been using this product for a number of years now. But if you'd like further information, we have test data at the Irrigation Research Foundation to back up what he's saying in hard copy. They are an independent research organization, and they test multiple plots. And one of the things that I've understood with them is that our seed treatment is so valuable to them that they actually use it on all their show plots, whether it's our test plots or whoever's product they're using, they use it. You've used APSA80 for a number of years now. Can you tell us a little bit on how much water you usually save in a given year, or maybe in inches or feet, something like that?
I can, Scott. Kind of the reason we have, for 25 years in our part of Nebraska, Dundee County, Nebraska, they've regulated how much water we can pump out of our wells. Okay. So they've run it on a 5-year period, and over the last 25 years we're allowed to pump 72 acre inches in a 5-year period. And if you use more than 72 inches in 5 years, you had to shut them off the last year or whatever. So records had to be kept, how much water we was pumping. That figures out about 14.5 acre inches a year. So we had to figure out how to raise corn, for example, that takes maybe 28 acre inches to raise a 200 bushel bushel crop. So we maybe get a little help, hopefully, from Mother Nature, but most people were pumping 19, 20 acre inches, and we were pumping 14. So we were saving on average about 5 to 6 acre inches a year. And we have records to prove that, and of course the NRCS keeps track of that, and if you overuse too much water, and last year they cut us down to 13.5 acre inches. So we get, and that's a 3-year period, so we get 40.5 inches in 3 years. So you can use more 1 year, but you have to figure out how to get by the next year. And so with the rotation of soybeans and corn, we get by with that. So we have good records, Scott. We know that you can probably save 4 to 5 acre inches on average, which we figure it costs us about $4 an acre inch to pump it, in our case, using electricity or diesel. And so, you know, right now this year we have about 300 acres of corn at $4. That's a big savings. Some pretty big bucks in our pocket that wouldn't be there otherwise.
So what you're saying is a farmer could save, based on your numbers of $4 an inch to pump it, if he could save 5 or 6 inches, he'd save anywhere from $20 to $24 an acre.
Yes.
So if a farmer does 1,000 acres of corn, that'd be $24,000 possibly he can put back in his pocket.
Right. That's good. That's just good math, good numbers.
So if we looked at it this way, if you used APSA80 at about $6.50 an acre or a quart per acre, that would be basically $650 on 1,000 acres, and your return would be roughly $18, $17.50 an acre.
Sure, on savings alone.
On savings alone, that's not even counting a yield increase, which leads me to the next question. About what is your average yield increase, A, in silage, and B, in bushels? What do you usually see?
We generally see, of course, we don't have test plots like they do here, where they can measure side by side, but we'll continually raise 220 bushel corn. We've been 240, 250 bushel on a good year. But and silage, we've been as high as 35 tons to the acre. We figure that's on average about 15% better than we would without. That just but here at the research station, they have exact numbers.
Okay.
I can tell you side by side, same variety, so they're accurate. But over the years, so increased yields. The other big thing that you have control. We can't always control prices that we get, but we can control our overhead, and we control it by less water, maybe less fertilizer, less population. Because using seed treatment and some of those, we get a better germination. So we use seed corn, or well, any kind of seed costs more money.
That's true.
And so that's another cost. So if you keep trimming a little bit here and there in several places, we figure on average you can save about $40 an acre between water, fertilizer, and population, and then minimum tillage.
$40 an acre on 1,000 acres. We're looking at, $40,000. Gentlemen, that is just enormous. I mean, just in savings. And if you factor in a 10% yield increase, say that you're doing somewhere around 200 bushels and you go to 220 like Stan's going, and a bushel of corn being $2.50, what do you got there? You got about $60 more an acre.
Yep. It's pretty substantial, and if it wasn't for APSA80, I'm not sure we'd be in business.
What else can you say? One of the other products you like to use is the NutriPlant seed treatment. What are the benefits you see with that?
Well, with the seed treatment, just a lot better germination. We've cut back on the amount of seed we plant, just knowing that we're going to get a better germination, and stronger plants. They survive better. You've seen plants where they'd come through and then they'd kind of wither over and die. You just don't see that with seed treatment.
Really?
It's just a weak plant that insects or something get to. Strong plants, it's like anything else. Insects and weeds don't attack the strong plant. It overcomes. So you got stronger plants with seed treatment, and it's cheap. I mean, so just like when we talk about overhead, I'm looking at, okay, what's it going to cost to put this on? Well, in most cases, $1 an acre. Well, how can you afford not to do that? It doesn't take long to save $1's worth of seed.
And that's a question. You say you use less seed. Most farmers use about a 32,000 plant population. What do you usually cut back to?
We're raising 220 bushel corn at 26,000.
So you're using 6,000 kernels of corn less to get 220 bushels. And what do you think that is in a cost for you on a given year?
You know, it varies, but it's probably seed. Of course, thinking about corn seed, of course, corn seed can vary. You know, as to whether it's $70 a bushel, but probably it probably saves $10 to $15 an acre, somewhere in that neighborhood.
So if we're using $1 worth of seed treatment, you're saving between $10 and $15 in seed.
Yes.
And raising the same amount of corn.
Raise the same amount of corn with less water, less fertilizer, and one pass over the field with minimum, or we use no-till drills, planters. Well, with anything, certain planters tell you to use graphite.
Right.
I wouldn't cut that out.
Okay.
That's a lubricant.
Okay.
Lubricates so that the planter works better.
Right.
But talc is, you know, this actually seed treatment. The carrier for it is talc.
So why use it?
Yeah. So you get all the fertilizer, the trace minerals. So anyway, yeah.
To put that into perspective, talc's about 80 cents per 100 pounds of seed, from what I understand. At $1 an acre, you're basically decreasing your cost. So your cost of your micronutrient actually goes down substantially. Probably anywhere 20 cents an acre to 30 cents an acre. So now your treatment's less than 80 cents. Hi, I'm Scott Fagora, and we're here at the Yuma Irrigation Research Foundation. I'm with Mike Peterson. Mike, can you tell me a little bit about yourself?
Sure. I'm the Area Resource Soil Scientist Agronomist for the Natural Resources Conservation Service for Northeast Colorado. Actually, I'm kind of regional now. I actually go into Nebraska, Kansas, Texas, Wyoming. I'm kind of getting all over, mainly because of what we're doing with strip till and the studies that we're doing here at the Irrigation Research Foundation.
Mike, I understand you've done some work with Ernie Brumbaugh where you authored a paper about the effects of a non-ionic surfactant called APSA80 on soil compaction.
Yes, we did.
Can you tell me a little bit about that?
That study ran in between 1996 and the year 2000. It was a 5-year study. It happens to be on the pivot that's called Pivot A here at the farm. It's directly behind me, off my right shoulder. And we did that study, Scott, so we were looking at the issue of compaction, because the soils here on the farm are very subject to compaction.
Okay.
Within the upper 8 to 10 inches, they'll compact really, really bad. And what we were doing is looking to see how better could we get water into the soil profile and how deep could we get roots to grow, because soil compaction is kind of a nemesis for most growers in eastern Colorado. And as we were doing that, we saw that as we applied a certain amount of the product against other products, always against the control, that the APSA products seem to be always riding right there, either number 1 or number 2 in the numbers of the products that we were applying. And we found out that we were helping improve yields, helping get roots to go deeper and water to penetrate faster. And that was really a thing that was, I think Ernie was after too. And with that, we came up with some statistical verification to what his product was doing, because we were applying it in the same area, the same time, the same amount every year with a control right alongside of it, so that we were doing a good scientific study.
One of the things it said in the paper is that you actually had a plot that you used with a ripper, and it actually showed that it appeared that the APSA80 outperformed the root depth compared to the ripping. Is that anything?
It did 1 year, yes. In the subsequent year, it was pretty much equal. What we did find was that when we did it in conjunction with a tillage tool, when we were looking at ripping tool, because these pans are quite deep, we were finding that it actually enhanced the tillage, so that it gave a chance for the roots to go deeper and for the plant to actually improve its capability to yield better. Because back when we first started this in 1996, our yields were 170 to 175 bushels to the acre consecutively. It was always happening. By the end of the study, we were up over 200. Wow. So we raised the goal every year because of the use of the product, and also just using it smarter, applying it at the right time, we were doing a better job of helping the water become more effective to grow a better crop.
And that was the other thing is, and of course you've worked with Stan Evans.
Yes.
And Stan has suggested that we have seen some water savings out of that use of that product. Have you seen anything statistically out of that?
What Stan and I have watched at he and his son's farm over near Hagler, Nebraska, is that we think that the product can enhance, because you're getting the roots to go deeper, we don't have to pump as much water, and the plant's going to be able to get access to the water. And we're thinking an application of 30 ounces per acre there's the potential to see that 1.5 to 2 inches of water saved.
Wow.
Because you don't have to pump it.
That's impressive. So basically for about $6 or $7 an acre, we can save a couple inches of water.
Exactly. And that can be a lot when you're thinking water's costing you $7.50 an inch.
Well, we got you going. I had one question. This is something that I was looking at. One of the papers you wrote is optimum nutrient uptake of corn roots for nitrogens of 54 degrees.
Yes, it's about 54 degrees.
What happens as the temperature rises? Does it stop taking nitrogen?
The plant slows itself down, and it wants the roots that are in the cooler soil to be able to get access to it.
So the deeper the roots would go,
yes,
the more nutrients will pull from that particular thing. This leads me to a question, a classification of a plant, meaning corn is a C4 plant.
Right.
So is that true with most C4 plants with the same nutrient uptake?
I'm not certain.
Okay.
But most C4 plants, see, they're storing their sugar at a different time of the day than a C3 plant.
Right.
And so the photosynthesis of the plant really depends upon when does it store its sugar, at night or during the daytime.
Okay.
And if it's during the daytime, that means that the plant has got to be able to tolerate a lot higher temperatures to be able to store the sugar. That's just a different.
Basically, you're talking a difference between a warm season grass and a cool season grass.
Yeah.
Okay.
Or a warm season plant versus a cool season plant.
What I was getting at is there some similarities that you might see with, since corn is such essentially Bermuda grass is such a nemesis of corn, and they sort of act the same way. Are they sort of doing the same thing at the same time? In other words, the C4 plant of a corn is looking at roots and having its nutrient uptake, and this Bermuda is sitting there trying to suck the same nutrients and putting roots down almost as deep, doing the same thing.
Yeah.
Okay. That was for some golf course things that we were working on, and that's kind of what I was getting at, because we're having issues where Bermuda in the summer is trying to just drive itself to seed, and you look at the Bermuda root and it's this deep. And and what I'm trying to explain to these guys, this is my own information, is that the roots are so shallow that the plant's thinking it's time to go to seed because it has nothing to pull nutrients from, because you're only 1.5 inches deep in your soil.
Right.
And so your soil temperature, this is thermal California, the soil temperature is 82 degrees at the first foot.
Yeah, or higher.
Or that's
in the surface inch it could be 100.
Yeah, at that time of the day. So what I'm trying to get at is, you're backing up what I theorized is, hey, take a look at this. If you have your roots at 18 inches where a Bermuda root could be,
yes,
you'd have a lot less problems trying to keep it alive.
And you're going to sustain it so that it don't start dying out, and you don't have the quality that the golfer wants to have. The turf is similar to what growing corn.
That's what I've been trying to show these guys, and I thought you might have some insight into that, because it's so similar, and what they're getting is they said, why can't we get it to grow out? I said, because your roots are so shallow, it's just pushing everything to the top.
And they're shallow operating their water application. They put on a little dab, and it just feeds the plant just for that day.
And that's something you said 2 years ago, is with this cold water, that if you don't get water deep and you have cold water on top of a corn plant, it gets lazy.
Exactly.
Because it says, oh, it's 50-some degrees, I got it right where I need, I don't have to do anything. Right. But basically, when you talk about APSA80, it's a tool that the farmer can have in his toolbox that he probably should have around for certain situations.
I think once you start it, if you are going to use the product, you want to keep it up. Because it doesn't show just 1 year's worth of great and wonderful things. The first year doesn't show all what you'd like it to show. It takes years. We always saw that, what Ernie and I saw was that the third year, that's really when it made its difference. And then the fourth and the fifth were just good gravy on top of biscuits.
Perfect.
Scott had a few questions for Lex. So let's see what Lex has to say about the APSA80 and the NutriPlant products.
We're here at Isleta Indian Reservation in New Mexico on Jaramillo Farms. with Lex Jaramillo. Hey Lex, how you doing?
Good, yourself?
Oh, doing good. Lex, can you tell us a little bit about the crops you grow here on your farm?
We grow straight alfalfa for horses and cattle, and spring oats, winter oats, and German millet, grass alfalfa, sorghum, wonder grazer, all kinds of livestock feed.
Excellent. Can you tell us a little bit about the APSA80 application you put on your alfalfa, how much water you saved?
Well, on this one 20-acre plot, we tried it, and we saved about 3 hours on this one particular field. It used to take 10 hours to irrigate, and now we cut it down to 7 after we used this product on the field.
And weren't you saying that it took normally every 10 days to do this, and now you're up to 20?
Yeah, we used to irrigate every 10 days because it's so hot and dry over here in New Mexico, and now we cut it back to 20 days in between irrigations.
So not only did the time per irrigation go down, but the distance between irrigations increased.
Yes.
So not only do you save 30% every time you irrigate, but you do it half as much.
Yeah, half as much, so we can do other things.
That's tremendous. Now when you applied the NutriPlant and APSA80 on your alfalfa, what kind of yield increase did you get?
Yeah, we had about a 24 to maybe 30% more crop yield than before.
And you were saying that that was on the third cutting, which is usually about 30% less than your second cutting.
Well, the second cutting first and second cutting is a pretty good yield, and the third cutting decreases by about 20 to 30% less. But after we use this product, we got about, let's say, anywhere from 25 to 30% more yield, matched the second cutting.
So money in the bank.
Money in the bank.
Excellent. And then you planted some sorghum using our NutriPlant SD product.
Yeah.
What kind of yield did you get from that?
Well, we put some of that stuff on the seed, treated the seed before we planted it, and we got about a 30% more yield using the stuff on that seed.
Just by putting the seed treatment on?
Yes, sir.
Hey Lex, thanks for your time.
Thank you.